Is my screen visible?
Yes.
Yeah, I think we can begin on this journey. All right, good afternoon, everyone. Thanks for joining in today on this Saturday evening. So the topic for this webinar is Discovering Computational Thinking in STEM. Let me make this as a presentation. Yeah, right. So yeah, we are trying to discover computational thinking in STEM, right? So we at EI have always thought or have always believed that CT has always been part of STEM. And teachers, students, or any problem solver for that matter, either consciously or subconsciously uses CT as, as part of the process of solving any problem, right? So through this webinar, we want to establish that link between computational thinking and STEM, right? And so this is a QR code which will take you to one of the WhatsApp groups that we have, where we post interesting questions every week. And we also share some fun facts about computational thinking. So these could be materials that you could take and use in your classroom setup itself. So it's like a good place to be and know about how computational thinking is evolving. Right now, let's look at the webinar agenda, like what we are going to look at today, right? So there are two major chunks. One of them is we're going to look at some questions that have been designed in the context of STEM. But the solution or the question that is asked in these contexts are computational thinking in nature, right? So we have topics of CT in physics, biology, e-commerce, computer applications, and mathematics. So we'll also look at one of a very old video, in fact, like 12 years old, about how engineers at Google were talking about computational thinking, right? And the last one is we also have ideas on hands-on, activities that we want to that can be implemented in classrooms. So these would be downloadable versions of the activity that you actually can take and use in your classrooms. So with that, let's quickly, look at what computational thinking is.
One second.
So this is
I
Janet.
I wanted to mention that this PDF will be shared on the WhatsApp group. So to receive the PDF, you'll have to be on the group. So we can pause it on the
Right.
WhatsApp QR code for about 30 seconds for those of you who weren't able to scan it.
Sure.
Like Bharat mentioned, we post a lot of questions for students for you to look at how CT operates in different contexts, in data, in logic problems, grid puzzles, all ways in which a child can be taught to think better, especially given what we're seeing AI do. I think this is very, very crucial for us to know first and then to pass on to our students.
Right. Sometimes we also add data, like student data, because these are questions that we share outside as part of Asset CT. So we also get data and insights on how students have answered. So that also is something that would give teachers a good idea about where students are making mistakes. Yeah, I think we can move now. So this QR code will also be available at the end of the session, so people can also join in there. Right. So we looked at the agenda and then we were just into understanding what computational thinking is. So this is Jeanette Wing. She's a very famous figure in the space of computational thinking. And her definition has been, very simple, and it's something that catches and it's very easily understandable. So the definition goes like this: computational thinking is a thought process involved in formulating a problem and expressing its solutions in such a way that computer, human, or machine can effectively carry out. So here, the central piece of this definition is that humans are the thought engines, because humans actually understand the scope of the problem and they are the one who come up with the solution. And once they come up with the solution, they would probably instruct another human or a team or maybe a computer through code, right, to execute that solution. So that's how computational thinking is seen. Next, we look at the skills that are there at EI for computational thinking. First, we'll have logical thinking skills, which includes logical conclusions and problem solving. Next, we have pattern recognition, wherein you identify certain patterns in a large data set, and then you figure out maybe this is what is causing a certain thing. So, for example, generally scientists across the realm, for example, say astrophysicists and scientists, they look at certain patterns that they are able to observe in the night sky, and then they create their hypothesis, right? So this is like a very important skill across domains. It's also pretty much used in, say, biology, any scientific or research-oriented place. Pattern recognition is quite useful. I mean, all the skills are, but this is extremely important. The third skill is algorithmic thinking. So once you have identified certain patterns in your data set, you kind of have to have a step-by-step solution for a computer to execute. And this has to be designed in smart ways, wherein you probably consider the efficiency of the computer, and there are other factors that come in. So these are all factors that you pull in when you're trying to think algorithmically and create solutions. So the smaller skills that you see, the two skills underneath every skill is the sub-skill that we have under each of these main skills. And we have debugging and iteration also as part of algorithmic thinking, right? And lastly, we have data analysis and data interpretation. As we know, there's so much data that is getting pulled in, right? And there is so many insights that we get from analyzing these data and identifying certain patterns, be it user preference. So for example, say a Zomato or a Swiggy, or for that matter, again, any scientific area. So analyzing data is a very important skill, and that is also as one of the skills in EI for computational thinking. So next, let us actually look at one of the old videos that I was talking about, right? About how Google engineers talk about computational thinking.
Computational thinking is.
I hope the audio is, it's audible, right?
We're not able to see it though.
Here at Google.
It's still on the slide.
Computational thinking.
Just give me a minute. Is it visible now?
Yes.
Yes. Computational thinking is a set of problem-solving techniques that we use here at Google. One aspect of computational thinking is decomposition, where we take a large problem and we break it down into smaller pieces. Another aspect is pattern recognition. We use pattern recognition to help us identify similarities and differences. The final part of computational thinking is algorithmic design. That allows us to create a step-by-step strategy for solving a problem. Google Earth is a perfect example of computational thinking because it takes a large problem of trying to visualize the entire planet and makes it so that anybody can explore the world around them.
Google Earth is basically an attempt to recreate the whole world in 3D. And we want to make it as if it's the real world. We don't want to make anything up. We don't want to create anything or invent anything. We want to make it the real world. And initially, it seems like this crazy problem if you really think about it. The world is huge. It takes a tremendous amount of data. we were to try to send this to you, we'd have to pull up in front of your house with tractor trailers full of hard drives of all the images. So it seems kind of impossible, but we make it possible. In school, you're given these problems that are very black and white. You either have the answer, you don't have the answer. You got it right or you got it wrong. In the real world, there are many right answers.
Google Maps is a collection of imagery and data about places and roads all around the world. And using Street View, we actually have images from cars right along all the streets. Once we collected all this imagery, you have to somehow put it together in a way to be able to share it with the world. Not long ago, I started getting annoyed with Peg. Pegman is the little yellow guy on Google Maps that you can drag to get into Street View. So you drag Pegman from the corner in Google Maps and you drop him on the street you want to get into and look at. That works great when you know exactly where you want to go, when you want to zoom all the way in on a single address and drop it next to a house or something. But say you just want to go to New York City. When I drag and drop Pegman, he falls somewhere, well, somewhere random. In fact, he seems to prefer to land in back alleys. He didn't mind landing in the middle of a field. He'd land on big highways, but he'd almost never land in front of a famous landmark. And if you drop on Paris, he'd never, ever land on. I thought to myself, we can do better than that. We kind of know what famous places are in the world. We should fix this. I began to think to myself, what makes a panorama, one of these images in Street View, important? And then I thought about it further. I thought, when people go places that are interesting, when they physically travel there, what do they always do when they're in a famous place? They pull out their camera and start taking pictures. People post a lot of these pictures to the internet. So we could look for places that people take a lot of pictures. We can find things that are in those photographs that people took and see if we can find the same things in the Street View images. And so if we can see the Eiffel Tower, the Street View image, and we can see it in a bunch of images people took, we can automatically know that it's probably important. We've worked really hard to make Pegman smart. When he's dropping from the sky, we want him to land somewhere interesting.
Thinking computational is a lot more like art than it is like math class. You go in and you know you want to create something, you have a blank canvas, and you use math, use these tools to paint on that canvas. And you end up creating something.
Right. Right. So we actually have a fun follow-up question on that, AV. So I'll just pose the question. So the question goes like this: how was Pegman made to land on famous places in Google Earth? Option A is engineers could not find a solution to this problem at all. Engineers had to take photos of every inch of the Earth. Engineers found that people took photos of famous places and engineers leveraged it. Engineers spoke to Pegman and asked him to only show street views if he thought they were famous. So we can have the poll for this. All right, I think we can show the results for this. All right. A lot of people thought engineers had to take photo of every inch of the Earth. So in the video, one of the engineers actually spoke about how it would be so difficult if they had to take every inch, the photo of every inch of the Earth. So the second person who spoke about, he kind of connected, he knew the solution space, right? He knew that people generally go to famous places and take photos, and they were also posted. So it is stored, say, probably in the cloud. And those images were actually leveraged as data. And then because of this pattern that he could find out, he was able to use that to make Pegman, a little more understanding towards what famous places are. So that kind of a thought process wherein, and real life problems are like this, right? Wherein you have every part, I mean, most of the data available, but you'll have to understand and figure out and abstract only those parts of the data that you want to solve that particular problem that you are trying to solve, right? So the right answer for this is option C, wherein engineers found that people took photos of famous places, and because they were stored in a certain server, they were used as data points, and that is what engineers leveraged and made pegmen place on a famous.
I think the misconception here is it's true that the engineers did take photos of a lot of places on the earth,
Yeah, correct.
but that is not the reason for pegmen landing in famous places. The problem was every other place was the same. Every place was the same as every other place. So for pegmen to land on those famous landmarks, they leveraged the photos taken by tourists or regular people to show that this is a more important or more popular place than just a side alley or just a field. So that's the correlation there. It is true that they took pictures, but that's not the reason for pegmen landing. Reason was they utilized popular pictures, most taken pictures.
Right. Thanks for that.
Good job, everybody who answered C.
Is my screen? All right. All right, let's get into the meaty part of the webinar. So the first set is going to be CT in science. All right. So yeah, so we actually pulled in few questions that we had that had context of, say, those particular subjects. But the question that you were asked for is based on computational thinking. All right. So this is the first question.
So the question says the thick black line below is a two-sided mirror. It means light can bounce off from both front and back of it. Based on how the mirror is kept, light coming in can bounce off in two ways. So here we can see in position 1, the light enters from the left side and it bounces from the mirror placed, and then it exit at the top of the thing. And in position 2, if the mirror is placed in another say, position, it enters from the left side and then it bounces off and exits at the bottom of the side. So the question is, light enters a
So this
box
is
with
another,
many.
yeah, sorry. This is another context that we're trying to set, because this is a grade 3 question. So we wanted to give them, also a context wherein these mirrors are placed inside these boxes, right? Yeah, Ashni.
Okay. So light enters a box with many mirrors at entry and bounces off of the mirror and leave at exit as shown. So we are giving the students an example of how light enters and bouncing and exiting from a different point. Now, in this box with 9 mirrors, light enters at entry. At which point will light exit? So we have 4 options. Option A, point T, option B, point Q, option C, point V, and option D, point W. Can we have the poll for this question? And what do you think the answer for this question is?
Yeah, I think we can have the results.
So
Only this.
27% of you answered option A, that is point T, and 35% of you answered option B, that is point U, and 27% of you answered option C, that is point V, and 12% of you answered option D, that is point W. So the correct answer for this question is option B, point U. We'll explain how that will be the correct answer. Can we move? Yeah. So in this, the light enters and then it bounces off and moves down. And then again it bounces off and moves on the right direction. And it bounces off and moves down and then again right, then up. And then on the left side, then it moves up. On the right side, down. And then it exits from point U. So this is how we apply computational thinking concept, but we use some concept of light reflecting from a mirror that we commonly see in physics subjects.
I think most of them got it right as well.
Yeah.
Oh, yeah. So this is another question where CT is used, say, in the context of biology. It's a purely logical reasoning question. So let me read out the question. Biologists often attach tracking collars to wild animals. For each animal, the following data is collected at frequent intervals: the animal's location, the date, and time. So the question is, which of the following questions about a particular animal cannot be answered using only data collected from the tracking collars? The options are: which are the locations an animal travels frequently to? Does the animal travel in groups with other tracked animals? Approximately how many miles did the animal travel in 1 week? Option D is, do the movement patterns of the animal vary according to the weather? You can take 30 seconds to answer. Yeah, I think we can have the answers. All right, so we have option B as the highest, around 12. So 38% for option B. And there's also the second highest is option D. Nice. Right. So the right answer for this is option D. So let's look at the answer. Right. So here we also see students, the way they have performed. So again, option D, this is for grades 7 and 8. So we have around 40% from grade 7 and 42% from grade 8 answer option B. So here people have also selected option B. Let's look at option B once. Does the animal travel in groups with other tracked animals? Right. And yeah. Yeah, so we have the animal's location, and we are saying if it can be tracked. I mean, the location of only that animal is tracked, but we are not looking at group of animals there. And hence, so we are looking at weather patterns in option D, which cannot be, figured out. But we can actually figure out if they have gone in groups because other tracked animals, because we have location of all these animals anyways. So option B is possible. This data can be, this question can be answered with these two, data if it is collected. But option D, we cannot figure out if weather actually has a certain effect on the movement patterns because we are not collecting that particular data in that question. Right. This is another question. Ashna, you're on mute.
No.
Yeah.
So this question uses the concept that is used in engineering and physics. So the question is, engineers use gears when they want to transmit motion from one part of a machine to another, or change the direction of motion between certain parts. Here is how two gears move based on how they are connected. First one is directly connected. The two gears move in opposite direction. So in this diagram, we can see one gear is moving in clockwise position and the gear that is attached to it is moving in anti-clockwise position. The second is connected by an open belt. The two gears move in the same direction. So, in the previous example, the two gears were actually touching each other, but in this example, they are not touching each other and they are connected by a belt. So if one gear move in clockwise direction, the other gear will also move in clockwise direction and vice versa. The third is connected by a cross belt. The two gears move in opposite direction. So again, these two gears are not touching each other, but if one gear is moving in clockwise direction, the other one is moving in anti-clockwise direction. So in the arrangement, this is the question in the arrangement below, which of these can connect gear X and Y such that the bucket moves up? So we have the diagram here. And can we get the options for this question? So option A is only Q, option B is only R, option C is either P or Q, and option D is either P or R. So our goal is to move the bucket upwards. So again, in the end, the gear is moving in anti-clockwise direction, and in the starting position, the gear is moving in clockwise direction. So how we need to connect the gear X and Y such that they go that the bucket moves up.
Let's have 10 more seconds. Yeah, we can publish the results.
So most of you have answered option C, that is either P or Q, and some of you have answered option B, that is like 22% of you, that is only R, and 28% of you, that is 9 of you, have answered option A, that is only Q, and 3 people have answered option D. So let's look at the right answers for this question. So the correct answer is option A, that is only Q, because in the starting position, this gear is moving in clockwise direction, and this gear is directly connected, like they are touching each other, so the adjacent gear will move in anti-clockwise direction. Again, the next gear is touching the previous gear, so it will move in opposite direction, that is the clockwise direction, and the next gear will move in anti-clockwise direction. So the movement of the X gear is clockwise direction. Now, if we start from the end position, it is moving in anti-clockwise direction. So the gear touching it will move in clockwise direction, and the gear adjacent to it will move in anti-clockwise direction. So we see that X and Y are moving in opposite direction and they are not touching each other. So the only connection that we could make here is Q, that is connected by a cross belt, because there is a distance here and the gear will move in opposite direction. So options in that sense, option A, that is only Q, is the right answer.
Right. Yeah, so this is the last question that we have in CT and science. So this is a fun question on floral formula. And Ashwini happens to be the creator for this particular question. So the question goes like this, the stem for it. Biologists often divide parts of a flower into concentric circles called whorls. A flower has 4 major whorls. So this is the representation of sepals. C is petals. A is the male part here that surrounds here. And G is the female part that is at the center. Right. Sorry for that. Yeah. So this is another example that we are trying to establish. To quickly communicate how these whorls are arranged in a particular flower, biologists use something called floral formulae. Take a look at the floral diagrams below and their respective floral formula. So for this particular image, this is the full floral formula. And for this is this, and this is this. So let's look at the question. Based on the naming pattern, what would the floral diagram for K6, C6, A6, G4 be? And these are your options. We can have the poll. Yeah, thanks. Can I have another 10 seconds? Yeah, I think we can publish the results. All right. Right, let's look at the answers for this. All right. So the correct answer is option B. I think most of you have got it right. So let's look at, so here and also in the previous questions, if you observe closely, the contexts have been from different subjects. But to answer these questions, there was no prerequisite knowledge as such required by the student to answer these questions, right? And also this kind of helps you or gives information about these subjects and various topics that are there in science subjects, right? So for example, this talks about, say, flowers, and the previous question spoke about, say, gears. So yeah, so let's look at the answer here. For that, let's look at the pattern that we actually gave as examples. So this is what is the key to answer this. So in this diagram, what we expect the students to understand or identify is that K is supposed to be the sepals on the outside. And we have a convention, or the naming convention goes like K and the number of sepals that are there, C and the number of petals, and so on, right? So if they are able to identify and match that pattern, they should be able to identify based on this formula, what would the flower look like? And that's how this question has to be answered, right? Yeah. So moving on to the next part, wherein we thought we'll share one of these ideas on animal sorting, right? So this is a computational thinking activity that is there as part of Mindspark CT, right? So that's like a web-based product that we offer for students to learn computational thinking and also hone these skills. So this is like the landing page for it, which has like a lot of these interactives that we have built, and they help in understanding and honing specific computational thinking skills, right? So we chose animal sorting specifically because it has the biology content, the connect to CT in it. So first, let us look at the objective of this activity. It's a very simple activity, and we thought this also can be used in a classroom environment, right? So first up, we have a list of animals or birds. So here we have an owl, tiger, peacock, and a deer. And then we have zones or areas into which we want to categorize or sort these animals and birds. So that is the second aspect. The third aspect is the brain or the thinking area, right? Wherein we have to apply these conditions. So here we have an if else statement. So here we are asking if animal, we'll have to select some characteristic about that animal and a value for that particular characteristic. And then we can send that to either zone 1 or zone 2. Else we can send it to, because there are only two zones, that's the way the if else statement is designed for. So let's look at the next set of steps. So we have this. Now we can, we can have this as type or diet. So these are two characteristics that we can classify these birds and animals into. So here we can either select diet or type. So here, for example, we are showcasing the right answer here. So if it is type, then if it is mammal, and then it is zone 1, right? So tiger and deer, both of them are mammals, and they are into zone 1. And the next condition else, whatever is left in that particular list goes into zone 2, right? So the correct solution is this. This is how the correct solution looks like, and this is how it appears, right? So now, like, what is the CT connect here, right? One could ask. Now, if, for example, say a student does not know these characteristics of these animals, right? So what we provide is a data set. And typically, again, we saw multiple examples before as well, wherein to solve a certain problem, which is, say, a large problem, we generally collect a lot of data and put it neatly, say right now it is in the form of a table, but generally that's how we do, right? We research, we gather data, and then we try to identify patterns. So for example, here, how does pattern recognition help you to answer this question, right? So that is something that we can look at. Now, if a student is provided with this table and they are able to read this table wherein they say, okay, I want the tiger and the deer together in zone 1. What are those characteristics that are common to these two? So they'll probably look at mammal and mammal, and then they can just choose type. So for example, let us take another question in the same data point, right? So for example, if zone 1 has the owl and the peacock, and the zone 2 has, say, tiger and deer. Sorry, zone 1 has owl and tiger, and zone 2 has peacock and deer. So that way, if the student is able to read and understand that, is able to understand that they'll have to choose diet as a characteristic, and they can choose carnivore. That way, they can classify these list of animals as tiger and owl, and then in zone 2, peacock and deer. So this also helps them understand certain aspects in, say, biology. Even if they did not know these facts, these could be given, and then the learning could happen in a reverse manner, wherein they apply and look at a certain solution, and through which they understand these characteristics as well, right? So there are more levels to it. So this is level 2, level 3. In the interest of time, we're just showcasing these, and in the PDF, if you remember that we're going to share in the WhatsApp group, we'll have all these things, added in the PDF, and we'll share it on the WhatsApp group. So we request you to join the WhatsApp group, for which the QR code will be shared at the end of the session. So this again is the data repository or the hint that can be used for level 3. This is level 4. So as you see, as the level increases, the complexity of the nodes also increases. The number of nodes increases. So we are also expecting the students to improve their data reading skill, like table reading skill, right? And this is another hint for level 4. This is level 5, and this is the hint for level 5. Sorry, the table for level 5. So all these things can be used in your classroom. So you can actually design this. We'll also look at how it can be implemented in a classroom in the further slides. So let's directly dive into it. So what we can actually do in a classroom environment is we can select a pool of objects that you want to sort, right? So this could be, say, for example, if it's a math teacher, you actually can consider, using objects such as numbers. You want to classify these numbers based on their properties. Is it divisible by 6, divisible by 7? Is it a multiple of 5? Is it a multiple of 11? So that could be a math example. If you look at, say, science, another science example specifically to chemistry, then you can actually classify or sort metals, non-metals, basically physical properties and chemical properties of matter, right? So you can have it as metals, non-metals, metalloids. So the sorting algorithm per se is a very generalistic algorithm. This can be used to sort any kind of material, and the applications go beyond just these subjects, right? So that is the first step. Second step is you can note down the characteristics of these objects in the table. So that is the hint that you'll have to create for that particular pool of objects that you have created. Then we can have students that have them write these names of the object, right? So we had cards here on the screen. So instead of that, what we can do is we can have students write names of these objects in an A4 or an A5 paper. Then what you can do is you can call upon these students with the object. So they actually are going to play the role of that particular object, right? So they'll be either the tiger or the deer in the previous example. And yeah, so you'll have to only call upon those students for which the level 1 has, those kind of objects that are there. Now, you can ask them to stand facing the class and display the name of the object. And if necessary, you can create, teams, and then you can pose the following question. So the question goes like this: if animals, for example, if it is going to be animals, then you say animals. If not, whatever objects that you've selected, so you can fill it there. If animals dash is dash, then send animal to dash, else send animal to dash. So this is basically the if-else statement that is broken down into a fill in the blanks. So now what we expect the students to do is answer this particular question, wherein they will fill based on the characteristic of that particular object, and they'll send it to zone 1 and zone 2. So number of zones can be split based on, you can say right of the board is zone 1, right of the blackboard is zone 2. So you as you're conducting the activity, you can actually assign certain places inside the classroom as zone 1 and zone 2. And once you've collected, say, 3 or 4 responses, what generally happens is there might be wrong answers and there could be right answers as well. So you collect 3 or more than that responses, and then we start simulating these answers in front of the classroom, right? And once we simulate it, if the student again is unable to come up with the correct solution, then is when we show them the table as a hint. Now, after the table is shown, the student will be able to, understand those patterns. If not, they can actually be, nudged towards that particular hint, wherein they see the common patterns that are there for these objects, and what would be the right kind of words that you have to fill this particular if-else statement with, right? So this way you can actually conduct the entire, say, this animal sorting, but this could be called as a sorting activity in general. And this could be used in classroom by, I think, almost all subject teachers for that matter, right? So yeah, so that's how we can conduct this in classroom, right? So now we segue into another area, which is CT. In STEM, we have covered science. We are looking at technology and engineering now. Yeah.
So, CT computer application. Computers and smartphone use a autocorrect feature to correct typing errors, often by calculating something called Hamming distance. Now, the Hamming distance between two words is the number of letters you need to change without changing their position in one word to convert it into other. So for example, the Hamming distance between horse and mouse is 2. So you can look here, like if you have to change the word horse to a mouse, you have to change the word from like the letter H to an M and then the letter R to U. So the distance would be 1 like for H to M and then 0 because you don't have to change the letter O, S and E. So 0 for those letters and then 1. So the total Hamming distance for this word is 2. Now the question is, which of these words is at a Hamming distance of 3 from create? So the options are option A, cheat, option B, cloud, option C, cheap, and option D, crack. So what do you guys think is the correct answer for this question?
Let's have 10 more seconds.
So most of you have answered option B, that is cloud, and 38% of you have answered option C, that is cheap, and some of you have answered option A and D. Now let's look at the correct answer. Can we move to? Yeah. So the correct answer is option D, that is crack, because we are changing the word create to crack. So in that, the letter C and R would remain the same. We are only changing the letter E to an A, and then A to an C, and letter T to K. So the Hamming distance for it would be 3, as it was asked in the question. So that is the correct answer.
Right.
Should
Let's look at another question. This is prevalent in e-commerce. So the question or the stem for this is, when you're buying a book from an e-commerce app like Amazon, there is a small chance that someone else buys the last copy of a book just before you click the buy button. Before an order is marked as successful, the program needs to confirm that the user has paid and that the copy of the book is available. So we've shown them a flowchart of exactly how it's going to work. So for example, if it starts, has user paid? So the program would check if the user is paid. If it is true, then they go here. Then if the book is available, again, that is true, then they change the order status to success, and then it stops. Similarly, we have another condition for false. Now let's look at the question. Again, this is the question. So if user has paid equal to, there is something that has to come in here, P, then there is Q. Book is available is set as true. Order success is also true. Else order success is, again, there has to be either a true or a false. So for the above code block to be equivalent to the flowchart, what should the values of P, Q, and T be? The options are P has to be true. I think we can reveal the results. All right. Most of you have thought it is option C. So let's look at the answer. Sorry. Yeah, so it has to be true and false. So that is true and false. So option B is the right answer. So we can't use or. So it has both of these conditions need to be true for the order to be placed. It's not that only one has to be true, and hence option B is the right answer. Yeah.
So let's look at another question, that is CT in networks. The question is, large companies sometimes connect their offices with a high-speed internet connection called a leased line. Since leased lines are expensive, companies look to provide this connectivity between as few offices as possible. So in figure 1, we have this connection that is connecting 3 offices, X, Y, Z, in this form. But we want to connect these offices using least number of connections. So that this can be done by in such a way, that is, we connect X to Y and then Y to Z. So we'll be able to reach from, let's say, the internet can be able to reach from office X to Z through Y. Now the question is, in figure 1, for again the same thing, the network formed by connecting X, Y, and Y, Z alone is called a spanning tree, and since it uses the fewest connection to connect the offices with each other. So in this question, which of the options is a spanning tree for the network below? So we have this network here, and what do you think is the spanning tree for this option, for this connection? So
We can have the answers.
So
No, no.
most of you have answered option B, and some of you have answered option C and D. So let's look at the correct answer. So the correct answer is option B, because again, we are using minimum number of connections to connect all the offices. So we can use, like we can reach from office B to office E through C. Similarly, all the offices are connected to each other. So that is the correct answer. Now, looking at the students' performance for this question is like most of the students have answered, like 57% of have answered option B, that is the correct answer. But you can see that some of them have answered option A, and that is this one. They are kind of misinterpreting and using one more connection more than option B. So in option B, we are making like 4 connections, but in option A, we are making 5 connections. So that is not the least number of connections. And can we look at the graph? And some of the students have answered option C and option D. So moving to CT in mathematics. So the question here is, see the number pattern in the pyramid below. Each number in a row has certain relation with a number in the row just below it. So we have this image here, and the student have to kind of understand the pattern that is there in this pyramid to fill the remaining circles in this pyramid. Choose the right order of the numbers that would fill up the empty circles, and the options are option A 3, 2, 3, 1. Option B 2, 3, 2, 1. Option C 1, 4, 2, 1. And option D 1, 4, 1, 1. So this question is based on problem solving, but the student need to perform some mathematical operations to get to the correct answer.
I think we can have the solution.
So most like 50% of you have answered option B, and then 27% of you have answered option C, and 19% option A. Let's look at the correct answer. So the correct answer is, as most of you have answered, is option B, because again, the order that we need to fill is 2, 3, because summing these numbers will give us number 5, and then 3, 2, summing these number will give us number 5, and then 2, 1, like summing these numbers, we get number 3. So that is the whole pattern that is repeated in this pyramid. Now let's move to the next question.
Yeah, so this is again a very simplistic looking question, wherein, but it's a nice question. So the hanging decoration below is called a mobile, where you hang different shapes on threads and try to balance both sides. So these are the shapes and this is the thread, and in total it says it is 100 units. So if the given mobile is perfectly balanced, then a pentagon has the weight of how many stars? The options are 2, 3, 4, and 5. Can we have the poll? Yeah, I think you can have published the answers, the results. All right. Yeah, more than 50, about 59% have chosen option A, and a lot of you have also chosen option C. All right. Since there are 4 stars, that could possibly be the reason. But let's look at the answer. So what do students say here? Right. The answer is option A, 2. And we see that a lot of, I mean, this is for grade 5 and 6. So here we see that grade 5 and 6 students have considerably answered option A as the right answer. But we also see a lot of students who have chosen option C as the right answer. Could be because of there are 4 stars that are, visually seen in that particular question. Right. So I think in the interest of time, we'll wrap this up and we'll go to the last slide, which has the feedback form. The request all the teachers, all the participants who have joined, kindly, this is the link to the WhatsApp group. So if you scan this, then you'll be directed towards a community or the WhatsApp group, wherein you can find the PDF for the animal sorting activity. It will be posted tomorrow. And on the right side is the feedback. It will lead you to the feedback form for this particular session. So request you to complete both of this.
Filling the feedback form immediately generates a certificate. So the way to get your certificate for the session is to fill the feedback form. Also, there's only so much we could take in a 1 hour session. There are so many things that we'd like to discuss with you. And there's so many ways and we would like to interact with you as well. So we're doing a workshop. It's a learning summit for computational thinking. It's a hands-on workshop where we will be talking about how you can bring computational thinking to your classrooms. We'll give examples from data visualization and analysis. Again, examples from math and logic, examples on using CT in art and how you can integrate that. And of course, using CT in science and technology. So all of this is geared towards making children think in a way that helps them navigate a very, very tech-centric world. Like Bharat had mentioned, humans are the thought engines. So the machines are there to carry out what you visualized, but they're also not, well, smart in the way we are, right? It is intelligence of a different kind, of a trained kind. So the original thought needs to come from us, which means problem solving, logical thinking, etc. will become that much more important. This learning summit is happening in Hyderabad. This is the first time that we'll be doing it, but there'll be many more such workshops coming. But the first one is happening in Hyderabad on the 5th of July of this year. So 5th of July in Hyderabad. We'll share more details on it now that you've joined the WhatsApp community. We'll constantly be sharing more updates on what the agenda is, what we'll discuss, who all is it, what is the intended audience. Although CT is so broad and so integrated with all subjects, we encourage all subject teachers to come and attend. So yeah, please stay tuned in for that. If you filled the feedback form, you would have immediately got your certificate. You can verify. It'll come in your email, whatever you entered in the form. And if you've joined the WhatsApp community, then feel free to leave the session. If you have any questions, happy to take them. So link for the feedback form, you just scan the QR code before you. And it's also shared on the chat. Faiz has shared it. So if you fill the feedback form, you join the community, you would have got the certificate and you'd have been accepted in the community. Then please feel free to leave if you don't have any questions. Thank you again for joining today.
Yeah, we have a lot of teachers joining in the community, which is great.
Yeah. So I'll just repeat, the way to get the certificate is to scan the feedback, and there you'll be asked for your email ID and number, name, etc. And that's where you'll get your certificate. The email ID that you specify there, not what you use to register. That's the way to get the certificate. Also, the WhatsApp community is where we'll be posting the PDF of the session that you just saw, all the questions that we took, as well as what you can use in your classrooms, how you can conduct these activities within your classrooms. So join that for those resources. And that's an ongoing place where we discuss questions that we are creating under computational thinking. We share interesting blogs and videos and other material for you to go through or refer. Because there's not as much information collated in one place for computational thinking. So this is a small effort towards that. We'll share more information on the Learning Summit. If you live anywhere near in the south of India, and if you can travel to Hyderabad for a day, I recommend attending the Learning Summit, because that's a full day workshop. There's much more than we'll be able to do in, say, 7 or 8 hours than in a 1 hour session like this. So it's more information dense, it's more hands-on. You actually get a learning kit that you can take back to your classroom. And of course, a certificate saying that you attended the workshop. All right. So thanks again for attending.
Right.
We'll end the session now. Have a lovely weekend, everybody. Thanks to Bharat and Ashna for hosting a lovely session, and for FAIRS for facilitating it. Have a good day.